In this lesson, we're going to learn how to solve equations with rational numbers. Remember that a rational number is any number that can be written as a fraction. Okay, either so that would include fractions. It would include decimals, as long as the decimals don't um, as long as the decimals end or repeat, as long as they don't just keep on going. And then also, obviously, it includes whole numbers, both positive and negative. So, um, anytime you're having any sort of operations with a rational number, then um, you can solve the equation. And what we mean by solving the equation is that we're going to find out the value of the variable. Okay, so to solve an equation, you isolate the variable by undoing the operation in the equation. This is called using the inverse operation. So, and we'll talk about that in just a minute. But so the first step, always the first step, is that you're going to draw a vertical line through the equal sign in order to divide an equation into two halves. Because whatever you do on one side of the equation, you have to do the same thing on the other side of the equation. Okay? And then the second step, obviously, is just to use the inverse operations to get the variable by itself on one side of the equation in order to isolate the variable. And so what that means, the inverse operations, is just simply that if you're adding a number to a variable, the inverse of adding is subtracting. So you subtract that number from both sides of the equation. If you're subtracting a number, then you add that number to both sides. If you're multiplying a number, remember, if you're multiplying, that would be something like 3x. That means that is equal to 3 times x. Okay, so if you're multiplying a number times a variable, you divide that number on both sides of the equation. So in other words, to undo or to use the inverse operations to get the x by itself, you divide by 3. And also, if you're dividing a variable by a number, you multiply that number to both sides of the equation. And so that would be like m over 7. Then you would just multiply by um, by that number. Okay, so pause the video and copy these notes into your notebook. All right, so the first thing we're going to do, remember, step one is to draw a vertical line through the equal sign. So now we have a left side and we have a right side. Well, on the left side, we want to get the m by itself. That means we need to use the inverse operation of addition to get rid of the 4.6 over here, and we're going to do the same thing over here. So we're going to say minus 4.6 minus 4.6. Okay, so 4.6 minus 4.6 is 0, so that just cancels out, and on the left hand side we have m is equal to, now remember, 9 is the same thing as 9.0. Okay, um, so remember that if you have a whole number, that the decimal points have to line up if you're adding or subtracting. So we borrow from the 9, make that 8, make that a 10. 10 minus 6 is 4. Bring your decimal point down. 8 minus 4 is 4. So the answer would be 4.4. The easiest thing to do, obviously, um, is just to use a calculator, and I don't mind if you do that. So 9 minus 4.6 is 4.4, just to double check. Okay? All right, next problem. This is a multiplication problem. First step, okay? First step, step one is draw our line. Step two is to use inverse operations. So the opposite or the inverse of multiplication is dividing 8. So we're going to divide both sides by 8.2. 8.2 divided by 8.2 is 1 times p is equal, okay, and so then we have negative 32.8, make it a negative, and then we're going to divide by 8.2, and we end up with an answer of negative 4. And remember, most of the time we don't, I mean, we never write down the 1, so just p is equal to negative 4. All right? The next one, this is the first step is draw our line, okay? This is a division problem, okay? So we're going, the inverse of division is multiplication, so we're going to multiply by both sides by 1.2. Okay, so this is 1.2 over 1, so that cancels with that. We're left with x is equal to 15 times 1.2 is equal to 18. All right. This is the same thing. Step 1, draw our line. The only little difference here is that we have the variable on the right-hand side rather than on the left-hand side. That does not make any difference. You still follow the same exact steps. So this is subtraction. The inverse of subtraction is addition, plus 4.2 plus 4.2. Okay, that cancels out. We're left with x on the right-hand side. 17 plus 4.2 is 21.2. Now, the other thing you could do if this just messes you up, just switch it around. Okay, but you got to make sure you keep it in the same order because we're subtracting, and subtraction order is important in subtraction. So we could say x minus 4.2 is equal to 17. Same thing. Add 4.2, add 4.2, x is equal to 21.2. Okay, so do whatever makes the most sense to you in that case. All right. All right. So those were all decimals. Now we're talking about fractions. The same steps, but we just need to remember. We need to remember our process for adding and subtracting, multiplying, dividing fractions. Okay, so here we're saying minus 2/7 minus 2/7. Okay, so that cancels out. We're left with n is equal to, remember, if you're subtracting, you have to have a common denominator, which we do. We subtract the numerators. 3 minus 2 is 1. And keep the denominator, which is 1/7. All right. Here, okay, draw our line. Step 1. Draw our line. We're going to add 1/6, add 1/6, okay? Actually, you know what I'm going to do is I'm going to put that 1/6 up underneath it because we have to write an equivalent fraction. So we're going to add 1/6. We notice here we have a 3 as a denominator and a 6 as a denominator. That means the common denominator is going to be 6. So we multiply the top equation by 2 over 2. That gives us 4/6 plus 1/6, which is 5/6. This cancels out. Y is equal to 5/6. All right. This is multiplication. To divide. Okay, so the inverse operation is division. So first of all, draw our line. The inverse operation is division, so to divide fractions, you multiply by the reciprocal. Okay? And remember, the reciprocal is just you flip the number. So we're going to multiply by 6 over 5, multiply by 6 over 5. Okay, this cancels out. We're left with x is equal to 30 over 40. Okay, and we can simplify that because 10 goes into both of them. Okay, it gives us 3/4. The other way of simplifying this is to plug it into 30 divided by 40 into your graphing calculator and hit math, enter, enter. Okay. The next one, once again, we have the variable on the right hand side. It's no big deal. We're going to say plus 1/2, plus 1/2. Okay. So this cancels out. We've got to have a common denominator. Over here we have an x. Okay. So 3/4. So we're going to multiply by, multiply by 2, multiply by 2. Okay, I'm going to go this way. So 2 times 1 is 2 over 4. So we have 3 over 4 plus 2 over 4 is 5 over 4. Okay, this is an improper fraction. So remember, the numerator goes in the house. All right, denominator goes on the outside. 4 goes into 5 one time. Okay, subtract. We have a remainder 1, which comes up and goes over the denominator, which is 4. So this is actually 1 1/4. All right. Make sure you understand all the different parts of this. This goes back to our unit when we were talking about adding and subtracting and converting fractions and mixed numerals. All right. The last example is 6/19 divided is equal to 3/8 divided by 3/8 times x. Okay. Okay, so multiplying, the opposite of multiplying is dividing or multiply by the reciprocal. Okay, so times 8 over 3 times 8 over 3, and that leaves us with x. That 6 times 8 is 48 over 3 times 19 is, I think, 57. And I'm going to double check. Yes. So 48 over 57. And then we can see if we can reduce that. What is it that goes into 48 and 57? Well, 57 is 7 times 8. 48 is 6 times 8. So we can divide both of these by 8. Okay. All right. No, I take that back. 7 times 8 is 56. Okay. 57. I don't think it reduces at all. So I can double check by pulling my graphing calculator up. Okay. Clear it out. You have so this cancels out. Let's see here. So let me pull that up. 48. Oops. So 48 divided by 57. Math. Enter, enter. Okay. So it is, that does reduce down to 16 over 19. Okay? Yes, obviously 3 goes into both of those, because we said 3 times 19 is 57. Okay? All right, so that 16 over 19 is the reduced one of those. Okay, so that does it for this lesson. Make sure that you understand how to do all of them. Make sure you ask me questions if you don't understand something, and make sure that you have all those notes copied into your notebook. We'll talk to y'all later.